Hello friends. Today we are going to discuss about the IRC 78 Part 2 2020, the limit state design for foundation. This code, as I said, was released in 2020, and earlier before this code, the WSM method for design of foundation was used. Now this code is introduced to make the design of foundation in limit state uh, and to align with it with the existing code of structures in which we are already following the limit state method from quite a sometimes. So this method is in this code is in transition or it is getting adopted. Some are still following the WSM method of old IRC 78, but sooner or later we all need to shift to this code. So the code structure is a bit complicated, I would say, for initial, so initial stages, or not complicated, it is somewhat different than what we used to do. So we'll try to understand this code in a lucid manner, in a easy manner, with the help of a flowchart. So IRC 78 Part 2 has three categories of design, or it caters three category of design, that is the open foundation, pile foundation, and well foundation. Today we are going to focus on only the open foundation. So as we see that the open foundation for limit state, we have two limit state. One is the ultimate limit state and second one is the serviceability limit state. Again, first thing first, if we go to the limit state, that is the ultimate limit state, we have two checks to be made. One is for equilibrium and second one is for strength. So when we go to the equilibrium part, the equilibrium means the check for overturning, sliding, etc. Now the equilibrium, the code says that you take the load factors from table B1 of IRC 6, which is say highlighted below, the partial safety factor for verification of equilibrium, which is given in IRC 6, and you take the material partial safety factor from table 1 of IRC 78. So you magnify the load based on IRC 6 and you reduce the property based on the IRC 78 table 1. Again, if we go to the, so this was the check for equilibrium, and again if we go to the right part of the chart, we will see the strength. Now strength, we have three factors. One is the load factor, second is the material partial safety factor, and third is the resistance factor. So all these factors are included in the code to take or to cater for the some kind of uncertainty. So the load factor caters for the uncertainty in the loads, the material factor caters for the uncertainty in the material properties that we have got from the site, and third is the resistance factor. So the resistance factor caters for the calculation methods or the theories and the assumptions between it that we have made to calculate the capacities. So if we see the load factors, what the code suggests is to use the table B4 for checking the base pressure and design of foundation from IRC 6, and it also says that for SV loading we have the combination 1. For combination 1 the factor shall be 1.15 and for combination 2 it shall be 1. IRC 6 says that it shall be 1.15, but this say supersedes the IRC 6 and says that for combination 1 the factor shall be 1.15 and for combination 2 the factor shall be 1. Again, if we go to the material partial factor safety, we see there are two sets, 1 and 2. So set 1 is to be used for the combination 1 and accidental load combinations, and set 2 be used for seismic combination and combination 2 of table B4. You can see here the table B4 combination 2 seismic, accidental, and combination 1. Now there is third factor, that is the resistance factor. Uh, so resistance factor has two types. One is for bearing capacity and second is for uplift. For uplift, we have to use, say, for anchorages R1 and R2. So for all cases, it is 1.1. And for bearing capacity, in case of soil, R1 is 1.3, R2, which indicates the seismic case, is 1.1, and R1, which is non-seismic case, we have to take 1.2 for case of SV loading. And for rock, R1, R2 both is to be taken as 4.5. So again, just let's move on to the serviceability limit state. So if we go to the right, we have serviceability limit state. For serviceability limit state, we have three checks to be made. One is the for contact area based on the frequent load combination, base pressure for rare combination, and settlement for quasi-permanent combination. So again, it has three factors: load factor, material, and resistance factor. So the load factor is taken from table B3 of IRC 6 and with buoyancy of 1. Table B3 specifies buoyancy as 0.15, but here we have to take it 1. The material partial safety factor is to be taken as 1, and the resistance factor is based on the contact area, base pressure, and settlement, based on what we are calculating. So for contact area, so it is not a factor, it is a condition. The soil contact area shall be 90%. For rock, contact area shall be 80%. That is for frequent combination. And for base pressure, the allowable base pressure in case of soil shall be the ultimate base pressure capacity or the ultimate base pressure divided by 2.25. For soil with SV loading, it shall be divided by 1.75. For rock, it shall be divided by 7. And for rock with SV loading, it shall be divided by 6. For settlement, the code suggests the settlement shall be calculated based on IS 8009 part 1, and it only says that the angular deflection in superstructure shall be within the limit of 1 in 400. So no specific values for this settlement criteria, only the angular deflection of the superstructure for differential settlement shall be 1 in 400. So that's all for the open foundation. In the next session, we'll see the pile foundation for the same code. So thank you. Hope you like the video. Thank you very much.